Chemical Spills and How Chemical Reactions Are Used to Remediate Them, by me, Jeremy Popskalski. Chemical spills? Some of you might not know what that is. Chemical spill is any spilling of chemicals outside or in a lab. There are two ways to class chemical spills: major chemical spills and minor chemical spills. Major chemical spills need to meet the following criteria. There is a fire or potential for a fire or an explosion. If the spill poses immediate danger to life or health. If there are injuries that require immediate medical attention. And finally, if you do not know the properties or hazard of the spilled material. Minor spills are spills that do not meet the criteria of major spills and can be dealt with relatively easily. What are the effects of chemical spills? Every spill is different, but they all have some similarities. They can kill or harm wildlife, destroy habitats, and contaminate critical resources in the food chain that can affect both animals and humans. Chemical spills can also affect the economy. Anything from destroying a farmer's crop to killing all the fish in a fishing town. Spills can also drive away tourism and temporarily shut down navigation routes. All of these negative effects can stay around for years and years. How chemical reactions are used to remediate the environment from chemical spills. In situ oxidation is a method of remediation for hazardous chemical waste in groundwater. This type of remediation is one of the most commonly used methods and involves reacting a chemical oxidant with a hazardous chemical. This in turn produces a less harmful chemical and is all done at the site of the contamination. There is not one single way of executing this method, but there are some oxidants that are used most often. Those oxidants include hydrogen peroxide, permanganate, ozone, and persulfate. The use of these oxidants in a reaction with a hazardous chemical provides a product of less harmful chemicals that can be extracted from groundwater, soil, and other sites. The neutralization of soil. One of the most commonly used ways of treating hazardous contamination in soil is neutralization. Reacting the contaminant with an acid, the pH levels of the chemical is reduced. This provides a less acidic product and the metals in the ground are then dissolved. These types of reactions we've gone over many times in class, so I'm not going to go too in depth as to the products and how it works. The basics are, when an acid and a base are reacted together, they produce water and a compound. In the case of cyanide spills, there are many methods, but I'm going to go over the two most common ones. First, we have sodium hypochlorite and cyanide spills. This is a two-step reaction where first the sodium hypochlorite reacts with the sodium cyanide, leaving sodium cyanate and sodium chloride. The final step is more sodium hypochlorite is reacted with the sodium cyanate and water. This reaction leaves you with three non-toxic products, which are baking soda, nitrogen gas, and sodium chloride. The second method is using iron 2 sulfate. This one is a three-step reaction. It starts with a double displacement reaction between the iron 2 sulfate and the sodium cyanate. The second reaction is a synthesis reaction that involves two compounds combining to create one new one. The final reaction is another double displacement reaction with two complex compounds. These three reactions resulted in a solid iron compound and a salt, both of which are non-toxic and easy to extract. Thank you for listening. I hope you enjoyed. And also, thank you, Ms. Dubois and Mr. McInnes, for everything you did this year.